All right, our next session here in the exhibit forum is about to begin. If you'd like to join us here for leveraging AI to boost productivity and quality of results in the digital design creation flow, please join us with Siemens here in just about 1 minute. Thank you.
Now the moon hides her face, the stars lost their charm. As I wander through the darkness, searching for some warmth, but your love still lingers in the depths of my soul. A bittersweet reminder, little bit of hope. Now the moon hides her face.
Good afternoon. People are still eating lunch. They haven't made it to this spot yet. But anyway, we are getting started. So I'm Ankur Gupta, and I am part of the Siemens EDA group. I'm a general manager for a digital design creation platform. And today's talk is about leveraging AI, which is on everybody's mind, to boost productivity and quality of results. Both things that you care about, right? QOR has always been important. Productivity is definitely very important these days. So first, let's start out with the challenges that we see in the industry. These are known to you, I would assume. There is the cost of doing a design at 2 nanometer, 3 nanometer. It's hundreds of millions of dollars. There is the challenge of shortage of talent. So the chart in the middle shows 67,000 engineers. That's the shortage that we are going to face in this decade. So that's a lot of engineers that are needed to get these designs done. And just graduating engineers coming into semiconductor and EDA is what we're talking about over here. Now from there on, if you look at how can AI help? AI from the perspective of creating design exploration type of capabilities on top of our EDA tools, it's estimated that there can be a 50% savings, which is significant because today's designs take 12 to 18 months to get through from concept to full silicon. And if you can shrink that by about 50%, that enables you to now get closer to the rate at which AI models are improving. There is a statistic that I read that says 4.3x per year. That's the growth in the size of models. So if silicon can keep pace with that, that's beneficial to the overall industry. And so here at Siemens, we are working on enabling exactly that. So here you see a map of different types of techniques, from machine learning to reinforcement learning to Gen AI to AI agents, and then finally agentic AI. There's a difference. There's a difference between AI agents and agentic AI. AI agents are more for single tasks, something that you know the algorithm for, but you're just outsourcing it, so to speak, to an AI agent. Agentic, on the other hand, is something that would take negotiation between multiple agents to get the full job done. I'll give you an example. Many of you, I'm assuming, are from the digital design creation area. So imagine that you're going through synthesis to GDS. You've got place opt, you've got clock tree generation, you've got route opt. For each one of those big monolithic steps, there's human in the loop. You're assessing whether the results look good or not before you decide to proceed to the next step. Now imagine something that is fully automated. That's agentic AI. That's got an AI agent for place hop, an AI agent for clock tree synthesis, an AI agent for route hop. And it's reasoning, it's taking decisions as it goes to finally produce results that can be manufactured. So that's the big concept. Once we get there, it's not a question of if, we are moving towards that ultimate objective. Once we get there, at that point, there is going to be this massive productivity boost, order of magnitude productivity boost that we are all looking forward to. And this concept at Siemens EDA is applied throughout the flow. So here on the chart, what you see is a full architecture to sign-off flow powered by industrial-grade AI. What do I mean by industrial-grade AI? In semiconductor, in chip design, you need accuracy, you need verifiability, you need to be able to trust the results, and that's what we mean by industrial-grade AI. Now, earlier yesterday, there was a talk by a colleague of mine, Amit Gupta, and a partner from NVIDIA, John Linford, Dr. John Linford. If you haven't had a chance to look at that talk, please review it afterwards. They go into a lot of detail on the Siemens EDA AI system that we just launched yesterday, which is essentially this industrial-grade AI. It's got these components that I've listed here, machine learning, reinforcement learning, for core algorithm improvement in terms of accuracy and so on. And then it's got Gen AI for a natural language interface. And I'll show you some examples as applied to digital design creation in a few moments. And then the AI agents and the agentic AI that you're seeing over here. So let's take a look at what does that, conceptually, what does that look like? You're looking at a flow today is designed with certain inputs that an engineer sets up. And then the front end of the flow is now, instead of just setting, here are my libraries, here are my scripts, you're doing prompts. You're setting up prompts. And based on those prompts, you get certain results, which is the EDA workflow. And then from those results, there is still human in the loop. But today, the engineers are setting up these runs, getting results, and instead of tasking them with doing that manual work, you've got an AI system doing that manual work, so that now the engineers themselves can take architectural decisions. For instance, they could take a look at a certain type of clock tree and the final results and say, well, what if I tried a different type of clock architecture? If that first part, if that front end of it is running really fast and is fully automated, then you have time left to do A/B comparisons between different architectures of a certain part of the flow. That's the idea, that's the concept. That's what gives you the order of magnitude speed up or productivity gain in the front end of the flow. Now the back end of the flow is very interesting. Here we are showing you some examples with machine learning and reinforcement learning. I'll specifically zone in on something like yield learning. Let's just say you've done a tape out, you've run tests, now you've got test failures. You've got to run diagnosis, and all of that is happening during bring up. You've got to run diagnosis, you've got to figure out what is limiting your yield. That is a big data problem. You can imagine that, right? Like hundreds of millions of transistors, a lot of intercept points in terms of the routes. So all of that data goes into a diagnosis system. Tessent in Siemens EDA has one. And then from that, you use machine learning, typically unsupervised, because you can't pre-train these systems. It's new data, it's unsupervised learning, to identify the needle in the haystack, to identify what exactly is causing the yield limitation. And that is the use of ML and RL for in that specific case is giving you orders of magnitude benefit. I'll show you an example of that also in a few moments. So that's the concept. So keep that in mind. Now, what we've done is we've taken these components and we have launched products. So Siemens EDA AI system, which I mentioned was launched yesterday, is an AI agents, agentic system that applies to chips, to PCB, the full stack. In the industry, other EDA companies have also done this, right? So the whole industry, the EDA industry is moving in this direction. Why are we moving in this direction? Because this is what you've asked for. This is what you, the customers, have asked for. And it has these key components which we see as boosting productivity while we have a compute time efficiency. So we have to be energy efficient in running these EDA jobs. And that's what's in the EDA AI system. To give you a peek into what we are doing at Siemens EDA. Number one, on the very top you see many of our key products are already leveraging this EDA AI system. So it's built into these products. I'll show you one demo of Aprisa, the product in the second row, using this system with a natural language interface. In a few moments you'll see that. Now the system itself is starting with this middle portion. You read it bottom to top. So first, we invested time and effort into building an EDA data lake, because general purpose LLM models don't really understand EDA language. So we've invested in preparing an EDA data lake and doing a domain adaptation for pre-training an LLM model for EDA. Okay, so that's the middle layer. The large language model is adapted to the EDA domain. We are agnostic to the type of LLM models that you use. You could bring your own. And then on top of that is the application layer. So there are assistants, there are reasoners. So the example that I was walking you through about taking decisions based on place op results and clock results and route results, that's reasoning. And then there are agents that would complete a task for you. So that's what we have in our launch. And now the question is, specifically to design creation, digital design creation, how do we leverage that? So to get to that point, first let's look at what is a digital design creation platform. And this is the platform within Siemens EDA. It goes from design architecture, moves on to implementation. At that point, halfway through this chart, a tape out happens. And then there is a whole post-silicon portion of the life cycle of a chip, right? The post-silicon starts with production. So this is where Tessent, I mentioned Tessent earlier. Tessent comes in, does the diagnosis for improving your yield. And then all the way into in-life. In-life specifically, we are thinking of, so think about the chip sitting in a, let's say, data center, right? So the chip sitting in a board, it's being used in a data center. There are different types of jobs that are being run on these chips. So again, take an example, think about an AI training job. These jobs, I'm told by customers, can run for 2 weeks, can run for a month on 10,000, 15,000 cores. What is the health of the chip as it's being bombarded with activity? AI jobs are very different from automotive jobs, right? Automotive as in a car is sitting idle for 6 hours, 8 hours a day. But an AI training job is keeping these chips constantly busy with high activity that can cause early life failures. So that's the kind of in-life capability that I'm describing over here, which can be monitored, and you can keep running periodic tests, full tests, all your ATPG patterns periodically. So that's the kind of life cycle challenges that we see and that we are addressing in our division of digital design creation. So with those solutions, how does AI help us? How does AI help us specifically for the two things that I mentioned in this talk, productivity and quality of results? Think about this as a progression over time. 10 years ago, we already had machine learning, reinforcement learning type of algorithms running under the hood of these EDA products. I'll give you specific examples. So Tessent Diagnosis, in 2012, we released Tessent Yield Insight with machine learning, unsupervised machine learning running under the hood because it was a big data problem, and we naturally used unsupervised machine learning to get to the root cause that we needed to. Last year at DAC, we talked about automatic macro placement in the Aprisa tool suite. So these things, the ML and the RL use has already been in our products for some time. Now what we are launching is generative AI with natural language interface for an engineer that is, let's say, a senior engineer who wants to solve tomorrow's problems with the latest, greatest features. How do they ramp up on the product? Gen AI provides that opportunity. Or a junior engineer. And a demo, you'll see a junior engineer can interactively work with the system to ramp up very quickly and get their job done. And then ultimately AI agents. So now let me start showing you some specific examples from our products. This one here is for the first case that I was describing, which is the Tessent Diagnosis. Each dot in this chart is a specific failure. And what you see over here is this is the actual silicon defect from the real chip. Our task at the top is to identify those failures as closely as possible. On the top, what you see is, this is with unsupervised machine learning, we are delivering an yield Pareto to say, well, the very likely cause of this failure is this. It's not always possible to get to a single cause, so it's a Pareto. In many cases, we narrow it down to 2 or 3 failure causes. With that data, you work with your foundry and you improve the yield 1%, 2% points. And that's, as you know, it's tens of millions of dollars for a 1% or 2% yield improvement at advanced nodes. So that's the power of a product that's in your hands today using machine learning, using reinforcement learning under the hood. So that's example number 1. Second example is an RTL to GDS space. What do the engineers in your teams do when they're designing these chips? They're building recipes. They're building recipes for full flows. Our idea, talking to customers, was use the recipes that smart engineers have already built and improve upon that using an AI system. This is different from some of the other commercial tools that you see out there. Some of the other commercial tools are doing parameter sweeps and coming up with the right parameter configuration. That will result in a cold start over and over again. In our case, we are, number 1, leveraging the best recipes from your experts. Number 2, we are writing out the recipe along with the best PPA results at the end of the task. What does that do? So your expert who came up with the recipe in the first place sees the result from Aprisa AI, and now you can see what did the tool improve? How did the tool improve upon your recipe? That leads to warm starts. That leads to reuse of those recipes. Another important thing is eventually we'll get to a point where we're going to be able to do this by design style. Interconnect blocks might require different recipes from CPU blocks and so on and so forth. This is very intuitive. So this is the key idea that we have behind the Aprisa AI capability, which leads to productivity and QOR. Now, talking about QOR, what you see over here is complete transparency of the results. So the chart on the right-hand side is showing you every single iteration of the recipes. It's pointing out the best recipe, the one that's highlighted with the yellow, the second column. That's the best recipe. It's also showing the next best recipe. Because when you set up the runs, you might have directed the tool to go for the least power. But later on, you might say, well, if I had a balance between power and area, what would I choose? That data is available for you to consume, fully transparent. So that's where we are headed with Aprisa AI. And I welcome you to go upstairs to the Siemens booth, take a look. We have demos. I'll show you a demo over here as well. But satisfy your curiosity, walk upstairs and take a look for yourself. The second piece is the generative AI example. Using natural language interface, we are able to generate examples of scripts, give you direct links to the sources. Extremely important for our industry, the semiconductor industry, is verifying where did the answer come from, right? You don't want to trust something unless you're able to verify the source. So we have that. There is a focus mode over here. Very interesting. So imagine that you're looking at power through the flow. You don't want to limit yourself to just one product. Like how do I optimize power in Aprisa? You want to open it up to how do I optimize from the RTL stage in Power Pro? What would you do in Aprisa? How would this translate to an EMIR result in Empower? These are all product names within the digital design creation platform. You can change the focus mode to cross-reference multiple products, or you can zone in on just one product. Hopefully this is all seeming intuitive. This is resonating with you because we've designed our system based on customer input. This is a demo now where you see, for a new user to Aprisa, let's say, how do I run route? You don't have to learn the language. You are going by your knowledge of the domain. It runs the commands. You can press that run button and it'll actually run the routing step for you. From there, you can introspect. You can look at a congestion map. So now I'm thinking, okay, how do I display the congestion map? So you don't know the Aprisa language yet, right? You're just looking at your domain knowledge and you're saying, okay, next I want to look at the congestion map. So it gives you the steps, it gives you the example commands, and now it also shows you the results. This is the sort of Gen AI capability designed for productivity that is embedded in the product, in the GUI of the product. Natural language interface meets the user where the user is in your own environment. So here is a critical path. That critical path is I've spent part of my career looking at critical paths and saying, okay, now what do I do? How do I optimize this? So this is all very intuitive, but 10 years ago, we didn't have the ability to have a natural language conversation with the product. Now you can. So that's what is exciting about the Aprisa AI launch that we've just announced yesterday. Many of these capabilities are going to be available soon, around the August-September timeframe. From there, take a look at agents. So here I'm talking about a debug agent, which is applied to DFT. And you can see a comparison between the traditional method with the AI agent. Again, natural language, very conversational. There is an assistant which suggests steps for current design, current mode. There is an agent which can then run the whole flow for you. So this is the next step to the Gen AI interface. Switching back to an RTL to GDS use case. I mentioned clock tree. So here what you see is a traditional method for clock tree generation is iterative, human in the loop. We are looking further ahead. So this is more or less end of the calendar year. So around December 2025, you'll see these capabilities come up in the product, where we will be able to do an AI agent for natural language interaction. You see that on the top left, create an H tree with a certain style of non-default rule, with certain anchor buffers to generate the overall clock tree. Think back to what I was saying at the opening of my talk, that you want engineers to be able to do A/B comparison of different styles of clock trees to meet your SKU requirements and so on, rather than focus all their attention on how do I run this tool. So we are taking that how away from your day-to-day task by making an AI agent do that for you, and the why and the what is something that the engineer can still focus on. So net-net, we think with these capabilities, the machine learning, reinforcement learning under the hood, the natural language Gen AI for an easy ramp to the product or an easy conversation for detailed analysis of certain difficult tasks like the clock tree generation, your productivity, your engineer's productivity is going to go up significantly, as well as the QR. Because what I didn't mention, maybe somebody can ask me this question, but I'll give you a hint. Through these recipes, what type of QR can I deliver back to you? That may be a question that you have in your mind. We can get into the QR and talk about that. To summarize, better QR with faster turnaround times with the ML/RL capabilities, productivity boost for the rapid ramp up. I hope I've shown this to you. I'm not just telling you certain things, but I'm showing you with the integration in the Aprisa cockpit that you can see that there is going to be a rapid ramp up for new engineers, and then massive engineering scalability once we get to the agentic AI system. So with that, I thank you for your attention. Definitely, we are excited about what we have launched here with the AI system as well as with Aprisa AI. There's a QR code that you can take a picture of that will give you access to the material behind a lot of what I described over here. And then we have our booth upstairs, 2611. Definitely feel free to stop by, see the demos that I described. With that, I'll pause. Thank you for your time. Any questions?
We have 2 aisle mics if you have any questions. 1 microphone in each of the aisles.
Okay, if no questions right now, let's, again, thank you for your time. Please visit us upstairs, 2611. Thank you.